In this video, we're going to be talking about how to solve multi-step equations, and in particular, how we solve two-step equations. The last video was focused on just one-step equations. This one takes it a step further, and I want you to see what the process is for how we deal with this. So I've got three examples up here. I want to work through these three, and as we work through them, I'll show you what the process is for going through and what a good method is for solving or getting started with multi-step equations. And we'll do more advanced ones in the future where we have variables on both sides and the distributive property, but for our purposes, I just want you to see what happens when there's more than just one thing going on. So let's start with this leftmost one. We've got 2x plus 5 equals 11. Now obviously we're trying to solve for x. It doesn't explicitly say, hey, solve for x. It won't always do that. I want you to be able to look at this and see, oh, I'm solving for x. That's what we want to do. And if you notice, we have a coefficient of 2 right here. So what I like to do is I like to put a little box around what I know we're going to solve. You can put a circle, it doesn't matter. But I like to put a circle or box around what I know we're trying to get to, what we're trying to solve for. And then we'll deal with that 2 at the end. So if you notice, remember one of the main steps, one of the big 2 rules for solving equations was anything we do to one side of an equation, we have to do it to both. That's known. And then the second one was if I want to get rid of something, I have to do the opposite operation. So you notice this 5 right here. There's a plus 5 going on. So go ahead and take a guess at what we're going to do to get rid of that 5. And if you guess minus 5, you're absolutely right. So I just subtracted 5 from the left. I'm going to do the same thing on the right side. And every time we do, so here's one step. If this was a one-step equation, we'd be done. But notice we're not done quite yet. These cancel out. This gives us a 6. I'm going to rewrite everything. And all we're left with is a 2x. Now, for most of you out there, you could probably take a guess at what the x is, but that's not the point of solving these. What we want to see is what is our actual answer? How do we get to it algebraically? Well, I see a 2x. Anytime you see a number attached to a variable, just like it was still the same up here, that's a coefficient. To get rid of that, we divide. There's a little bit more of a different type of way to go about that in the future when we have a fraction coefficient. We're not worried about that now. For here, I'm just going to divide 2. And again, we do that on both sides. And if you look, we get x equals 3. So just to reiterate, what we did is we kind of looked and saw, okay, well, 2x, we'll save that for the end. But I noticed there's a plus 5 that I want to get rid of from that same side with the variable. We do the opposite operation. That was step 1. And then we went down, I saw, okay, well, we have a 2 attached to our x. Now we want to deal with that. We don't care about what 2x is. We want x by itself. Here's step 2. We divide by 2. And then we get our answer. And one good thing you want to do every time you solve an equation, especially on a test, is go back and plug in your answer. If I plug in x equals 3 up here, 2 times 3 is 6. 6 plus 5 is 11. 11 definitely equals 11. That's how we know we got the right answer. And that's pretty much it for that one. So taking that same idea, let's take a look at this next example. Try this one on your own and then come back and let's see how we can work through this. Okay, so hopefully you tried this one out and work with it. Maybe you got the wrong answer or the right answer. It doesn't matter. All that matters is that you're practicing. So I see this one. I'm going to put my little square around this, 3x. I see a minus 6. I want to get rid of that. So the opposite of that, the inverse operation, if you want to be exact, is plus 6. I have to do that to both sides. That's step 1. So, whoops, let's try that again. Oh no, it's going crazy on me real quick. So we get rid of that. And then once we rewrite the equation, it looks like we get 3x equals 30. Okay, so we're close. A lot of times I see students say, okay, our answer is 30, we're done. Very tempting, but we have one more thing. Again, we don't care about what 3x is. We want x by itself. So our second step, if you can take a guess, if it's 3 times x, to get rid of that 3, we have to exactly divide by 3. And I'm doing this like I'm asking my students. So that's why there's the pause. Let's see. So these cancel out, and we get x equals 10. Now again, we go back. Let's double check. If I plug in 10 for x, let's get rid of this. Whoops. If I get rid of, let me lock this in place so I don't erase it. Let's plug in 10 for x. 3 times 10 is 30. 30 minus 6 is 24. 24 definitely equals 24. So when you get something that's a true statement like that, that's how you know that your answer is correct. If you happen to get something like 5 equals 24, then we definitely need to go back and see, okay, what happened? Maybe I added a negative or put in a negative or took out a negative accidentally, stuff like that. Now, a little bit different. I do want to get some practice with division. All we've been doing is multiplication coefficient so far. So take a look at this one and try it out, and then come back and we'll go over this. So at first glance, obviously it's a bit different. It's not just a nice whole number attached to our variable. We have a little bit of a fraction. Technically, this is 1/7 attached to it. But I still see something else on the left side that I want to get rid of. I see a +9. And if you can take a guess, it looks like we want to subtract that. Now, once we do that, let's rewrite. So this is step 1. Once we do that, we just want to rewrite the equation. Looks like we have still x divided by 7. That just didn't disappear on its own. I wish it did, but it didn't. And we get this. Now, there's a couple ways we can look at this. When I see this one, what I want you to notice is this is x divided by 7. So the same process applies. We want to do the opposite operation. The opposite of division is multiplication. So that's a multiplication symbol. We want to multiply by 7 because 7 over here, 7 divided by 7, those cancel out to 1, and anything we do to one side, we have to do it to both sides. And it looks like we get our x by itself. That was step 2, by the way. So we have x equals 6 times 7. That's just 42. Now, again, just to double check, if I plug back in x up here, 42 divided by 7, that's 6. 6 plus 9 is definitely 15. And 15 equals 15. That's how we know we got our correct answer of 42 down here. So just a few examples of multi-step equations, just the beginning. Now I say multi-step, somebody out there would probably correct me and say, okay, it's not multi-step if it's two-step, but a two-step equation is just a good way to get our feet wet with the multi-step ones that we do a bit later, where we have multiple variables that we need to combine, variables on both sides. I'm sure many of you have probably heard that or seen that coming up. That's going to be the next video where we jump into those. But I do want you to see how we approach these types of problems where we need to do something first to isolate our variable. That's what we've been doing this whole time. I probably should have mentioned that. We've been isolating the variable, and then we can solve and get rid of whatever the coefficient is. So I'll put some examples in the description for you to try, and I'll provide the corresponding, I can't even think, the corresponding answers to those, just so you get some practice and make sure you're comfortable with this idea. Because solving equations, these two steps that we're doing, getting rid of one thing, doing the same thing to both sides, is the backbone of solving almost any equation. So I want you to be 100% comfortable with that. And then the next videos, we're going to be doing the more advanced ones. So stay tuned for those. Hopefully this video helped you out, and we'll see you next time.